This next video concerns itself with another type of file format that called JSON. So JSON is short for JavaScript Object Notation. It's a plain text format, much like CSV, meaning it just has normal characters. You can read it with your own eyes if you want to. Although it originally came from JavaScript, you can see it in the name, JSON is language independent. You can use JSON from Python, C, whatever language you want. It's just like CSV, it's not tied to any particular language. One important difference that we covered in like the last multiple choice question is that white space outside of specifically designated strings isn't meaningful. So you can break up lines and things like that and make it so that it's easier to read than often the really densely packed CSV format. And the way that things work is JSON, a file in JSON is one data type per file, but often that single data type is really a container that contains many other things nested within it. JSON is really structured to allow for this kind of nesting of going deeper and deeper into particular parts of that data format. So let's start by talking about how strings are represented in JSON. I'm going to use this kind of interesting image way of denoting what a string is. The idea is a string, you start on the left side and you try to get to the right side. Okay, and so in words, what is a JSON string? It's a 0 or more Unicode characters, but really ASCII is a subset of Unicode, so we're not going to be doing anything with Unicode in this class. So every time I say Unicode, just replace that with character. Strings are delimited with double quotation marks, and you're allowed to escape various things with the backslash, much like you're used to in C or C++ or Python. So an example string is below. It's double quote hi /n everyone. And so the first character of this string is that capital H. The last character is that one. That /n is really just one character, just like you're used to strings in many other languages. And so the way that you can see this with the diagram on the left is you have a double quote, and you can either go and take the fork going up, which then just goes to the other end and with the closed double quote, so you can have the empty string. Or you can do a double quote, and then you can go and do one of those slashes, and then after the slash you have to have one of those other characters, and then you can go to the double quote at the end, or you can cycle around and add another character. And this time we could go the straight path and just add a normal character that's not a double quote or a slash, and then we go and repeat and so forth. And so this image is a way to represent, here are all the possible strings that can be formed by going from this left, right, and taking loops when you would like. Okay, so just to make sure that we're comfortable with what a JSON string is, let's go to a multiple choice question. I want to know which of the following strings are valid, are strings within JSON. Okay, so is the first, that JOSH, is that a valid string? No, it's not delimited by double quotes. That's not a JSON string. Is the next one a JSON string? Well, you have the double quote and you have character, character, character. Then you have a slash, and the thing after the slash is an N, which is allowed, and then you end your string. Is that a valid string? Sure. What about the next one? Double quote, we're off to a good start. We got a slash, and then the thing after the slash, wait, we have an underscore. Is underscore legal after a backslash? No, it has to be quotation mark or slash or the other type of slash or B or so forth. There's no underscore allowed there. So is this a legal JSON string? No. And now the last one, just two double quotes. Is that legal? Sure. Double quote, and then you don't have to include any characters between the double quotes, and you close with another double quote. So which of these are valid JSON strings? All of them except for the funny pink one. Okay. Next, we'll talk about numbers. What are valid JSON numbers? Well, it's a signed decimal number that may contain a fractional part and may use the exponential E notation. How does this actually work? Well, here's another diagram. We start on the left, and we say there's an optional minus sign. I can either take the straight path and not include a minus sign, or I can divert down. And then I can include a leading, a 0, or I can include the digits 1 through 9. And if I include the digits 1 through 9, I can include more digits, so 0 is a legal number. But otherwise, you have to start with a 1 through 9 and include the rest of the numbers. And then there's the optional dot and more decimal digits. And then there's the optional E notation using capital E or lowercase e. You can have a signed scientific notation, and then you can have as many digits as you want to end. So here are 4 examples of JSON numbers: 4, 12.5, 6 point something, raised to the 23rd. I think that's Avogadro's number, and negative 5.6. Those are all valid JSON numbers. Okay, that's not too hard to grasp. What about arrays? Now, arrays are a collection. It allows you to have an ordered list of 0 or more values. So the way that you denote an array is you have to have a open square bracket, and then you have to have a closed square bracket at the end, and in between you have various values separated by commas. Now, what are values? Values are any other JSON data type. So number, strings, arrays, and a few more that we'll get to. Okay, so we have 3 JSON arrays here. The empty array, an array with 3 things: a number, a string, and then one type that we haven't got to yet, a boolean. We can have and we can also do nesting, where you have, here's another array. The first element is an empty array, and then another one is the null object, which we'll get to in a little bit as well. Next, we can talk about objects. Objects, like arrays, are containers. However, this one is unordered. It's a list of name-value pairs where the names, sometimes they're called keys in various documentation, are always strings. This is like a Python dictionary with the rule that a key must be a string. So we have a valid JSON object down here. It has the open curly bracket. We have a string, which is name, which maps to the value Josh. We also have another key, age, which maps to the value 17, and we have another key, section, which maps to a particular array. We all good here? So what is a value? Because we said, you can include values in arrays, you can include values in objects. Well, a value is basically any of the above types: string, number, object, array, and you can also have Boolean values, true and false, and you can also have the null type. All right, so let's look at a more complicated JSON example. So this one is a JSON file. If I copied and pasted this into a file and named it .json, this is a JSON file. It has one data type inside it. What's that data type? Well, it starts with a curly bracket, so it must be a JSON object, and it has various keys of name is Josh, pets, and then the pets maps to an array, and inside that array there's a object, and inside that object there's a mapping of name to Zoe, and age to 7, and birthday to null, and species to dog, and commands to another array that contains a list of, in this case, strings. And then we also have another key in the big dictionary called employed, and it maps to true, which hopefully I'll say that way. Okay, so that is the JSON file specification. Now, like CSV, you can use schemas with JSON. Once again, what is a schema? A schema is a definition of how data for a particular use should be formatted. Schemas are used for validation. And so there's a number of JSON schemas. However, the primary one is the one that I'm going to be showing you here, which is located at the link provided. All right, so let's talk about, say, an example, a simpler JSON file here on the left. We have IDs, names, price, tags. It's meant to represent, say, an entry in some inventory database. Okay, and so what a schema can do is it can provide constraints again on what is allowed data. So for instance, it should specify, I'm just assuming that this JSON object represents some sort of inventory. The schema can actually say what the thing is supposed to represent. It can also specify, like, what does ID actually mean? It could say, hey, is the name an actually required field? It could specify what are allowed prices. For instance, can the price be 0? And then it can also say, hey, tags is meant to map to a bunch of maybe information regarding the product. Is all the information required to be strings? The schema can require certain characteristics. So let's build a JSON schema. So we can start with by handling the what is the thing, what is the data. And so we can say, hey, for this schema, these things are products. And these things are meant to be products from a particular catalog. And the type, the base type for the JSON file should be an object. If you supplied a list or something else, or excuse me, an array or something else, it would be invalid. It would break the schema. Okay, now let's say we want to add some constraints onto the particular ID key. So what is ID? We could say, okay, in this object, the properties it contains should be an ID. And what is an ID? Well, it's a unique ID for this thing. And what is its type? It must be an integer. It must map to an integer. If it doesn't map to an integer, it's broken. And then I can also specify in the specific required tag to say, hey, here are all of the fields that are necessary for this JSON file. And right now, the only thing that's necessary is an ID. Okay, so let's work our way down. We can also add specifications for name. So we can say, hey, what is a name field? Is supposed to be the name of the item. What is its value type? It should be a string. And we can say, names are required for every piece of inventory that we're trying to add to our database. So it should be required as well. All right, working our way down, we can say here is price. Price, what is the type of price? Well, it has to be a number. It doesn't necessarily have to be an integer, but it has to be a number. And the minimum should be 0. We didn't specify a maximum, so I guess it can go as big as it wants. And we can even say there's an exclusive minimum, meaning you're not allowed to actually be at the minimum. So can the price be 0? Not in this case. And we could say, hey, everything in our inventory needs to have a price as well. All right, and now let's handle tags. So what are the rules for tags? Well, in this case, I can say tags needs to be of type array. Okay, so even if it's one thing, it still needs to be an array. And we can say, what is the type of the things in this array? Well, they have to be strings. And you can even specify things like this array needs to have at least one thing, and everything in this array needs to be unique. And note, however, I didn't add the tags to the required item. So an inventory item doesn't need to have tags, but if it can, it needs to have at least one that's a string and so forth. Okay? So are JSON schemas required to interpret JSON data? I guess that really kind of depends on what you mean by that. But in reality, no. You can work with JSON perfectly fine without any of these schemas used for validation. These are really primarily used to make sure that when you're taking in data that it's well formed, that it's valid, that it's able to be processed in a way and it contains the data that you are expecting. You don't have to use schemas, but they're very useful for safety. And now, once again, all of the schemas that I'm going to be talking in these series of videos, I'm not expecting you to memorize any of the details. I'm never going to ask you on an exam, write up this schema. But I want you to get a feel for the difference between what is legal JSON and what is valid schema.